Large intestinal absorption. Lots of material enters, lots of material reabsorbed. Okay, so this is a concentrating organ. All right, so very fluid chyme comes in to the large intestine. What leaves the large intestine is semi-solid. Right, so that means that a lot of fluid has been reabsorbed. 1,400 of 1,500 mLs that enter. Now, what's absorbed? Almost all the ions, okay, because ions are precious, hard to find, okay, a lot of the water, not all of the water, but a lot of the water are reabsorbed. So the feces actually has very little in terms of ionic character. The large intestine is very efficient. Most of the absorption happens in the first half. Okay, so similar to the small intestine, most absorption in the small intestine happens in the first half too. So same idea. Now in the large intestine, we have this weird situation where what's in the lumen, we do not want in the body, right? So we need to have like a blockade. So between the epithelial cells of the large intestine, which do not have microvilli, okay, they're smooth, all right, because that helps them stay safe. There's tight junctions between them, so that material in the lumen can't squeak between the cells and get into the body. Because remember, that's shit, right? It's nasty stuff. So we want to keep it out of the body. So tight junctions are doing that. The large intestine absorbs a lot of sodium. That's active transport. Okay, that's our sodium-potassium pump again. Chloride follows electrically. So the vast majority of absorption is sodium and chloride. Probably potassium would be the next biggest one. Then there is a small amount of secretion. Bicarbonate ions, I think we talked about this yesterday. Bicarbonate ions are secreted by the large intestine to offset the acid production in the bacteria, or from the bacteria. So we absorb sodium and chloride actively, all right, and then water follows, just like we saw in the kidney. Okay, it's the same idea. Move the salt and the water follows along behind. So what we absorb on purpose is the ions. What we get is absorption of water and ions, right? So that in the end, what we have is what comes out the other end, the feces composition, right? So 3/4 of it water, 25% solid. Obviously, this is going to vary immensely, depending on a lot of factors. Okay, what's in the solids? 1/3 of it's dead bacteria. That stuns me every time I look at it. Like, that's a lot of bacteria. It's just saying, right? So that's 10 to 20% is fat. There's always a small amount of fat in there. 10 to 20% inorganic, some protein, lots of undigested fiber. This 10 to 20% fat, in a perfect world, this would be 0. If we were perfectly efficient at absorbing fats, this would be 0. But if you look at the human diet evolutionarily, right, the fats we get either come with carbohydrates, and they're in small amounts, or they come with meat, and they're in relatively small amounts, right? So one of the problems, one of the reasons for this is, quite frankly, we eat more fat than we need, right? And we're not particularly good at digesting it. The color of feces is usually due to bilirubin. Bilirubin is a breakdown product of heme. It has a greenish-brown color, depending on its electron state. Okay, so that's where the color comes from. And the odor is usually from products of bacterial metabolism, right? Bacteria have sulfide metabolisms that we don't have. So hydrogen sulfide is one of the classic ones that bacteria make that we don't. Our bodies don't know what to do with sulfur, so it comes out the other end. The microbiome plays a big role in what kind of bacterial metabolism is happening, and therefore what the odor is like, but also like what the gas production is like and all that kind of stuff.